This video tutorial takes you through the individual steps involved in fabricating a hybrid abutment using IPS Emax press and the Viteo Base titanium bonding base. First, select the titanium bonding base that matches your implant system. Insert the Viteo Base into the model and screw it to the lab analog. Now select a matching Viteo Base press sleeve in size SD or MD. Place the sleeve on the titanium bonding base and check for an exact fit in the area of the screw channel and the marginal shoulder. In the case shown here, the Viteo Base was shortened from 6 mm to 4 mm. This means that you have to shorten the Viteo Base press sleeve accordingly so that it matches the height of the Viteo Base. Use a diamond-coated separating disc to shorten the Viteo Base press sleeve. Bear in mind that the restoration must be able to fit accurately on this area later on. Isolate the Viteo Base at the transition zone to the Viteo Base press sleeve. Isolate the Viteo screw channel pin and insert it into the screw channel. Then, shape the restoration directly on the shortened Viteo Base press sleeve using wax or modeling resin that burns out without leaving residue. Now, select a matching IPS Emax press investment system. Seal the opening of the investment ring base with wax and measure the weight of the investment ring base. Write down the weight. Now sprue the wax up using 2.5 mm thick wax wire. Align the wax wire as parallel to the screw channel as possible. The IPS sprue guide is an auxiliary that helps you visualize the positioning options of the restorations. Make sure that the wax up and press channel do not exceed a maximum length of 16 mm. Now measure again the weight of the investment ring base, this time together with the sprued wax up. Calculate the difference between the empty and loaded investment ring base. This is the definitive wax weight of the object to be pressed. Use this weight to choose a press ingot in an appropriate size. Carefully place the IPS silicone ring on the investment ring. Prepare the investment material according to the instructions for use. Make sure not to inhale any dust particles. Fill the IPS Press Vest Premium investment material into the investment ring. Pour slowly so that the material can rise steadily. Best use a vibrator unit for this task. The slight vibration enables the investment material to spread evenly. Continue to fill the investment ring up to the marking. Position the IPS ring gauge with a hinged movement and press it down onto the IPS silicone ring until it stops. This allows any surplus investment material to escape through the opening. Leave the invested ring to set without vibration. After the setting time has been completed, remove the IPS ring gauge with a turning movement and carefully push the investment ring out of the IPS silicone ring. Now, remove rough spots on the bottom surface of the investment ring using a plaster knife. Make sure that no investment residue enters the sprue channel. If necessary, carefully blow out the sprue. Check that the investment ring sits at a 90-degree angle to the tabletop. Now, place the investment ring into the preheating furnace with the opening facing down. To ensure that liquid wax can flow off easily, the investment ring should be positioned as close to a 45-degree angle as possible. Whilst the investment ring is undergoing the preheating cycle, carry out the preparatory steps for the press process. Isolate the cold IPS Alox plunger with a coating of IPS Alox plunger separator and keep it ready, together with a cold IPS Emax press ingot in the suitable shade and size. Once the preheating cycle has been completed, remove the investment ring from the preheating furnace. Then, place the cold IPS Emax press ingot into the hot investment ring. The printed side shows upwards. Place the cold IPS Alox plunger into the investment ring. Using investment ring tongs, place the loaded investment ring at the center of the preheated press furnace. Either select the appropriate press program for IPS Emax Press, or if you use a Programmat EP5010, select the fully automatic press function. Start the press procedure. As soon as the optical or acoustic signal has indicated the end of the press cycle, remove the investment ring from the furnace with the help of the investment ring tongs. Place the investment ring on a cooling tray. Do not speed up the cooling process. The investment ring will have cooled to room temperature after about 60 minutes. You can now start with the divesting procedure. First, mark the length of the IPS ALOX plunger on the outer surface of the cooled investment ring and apply a separating disc here. This way, you create a predetermined breaking point. The predetermined breaking point enables a reliable separation of the plunger and the ceramic material. Carefully break up the investment ring by hand. Rough divesting is carried out by blasting with polishing beads at a pressure of about 4 bar or 60 psi. For fine divesting, reduce the pressure to 2 bar or 29 psi, again using polishing beads. Observe the distance between the jet nozzle and object and the blasting direction to prevent damage to the ceramic restoration. To remove the reaction layer, first immerse the pressed object in IPS Emax Press in Vex liquid. After the restoration has been rinsed under clear water and dried with blown air, the pressed object is carefully air blasted. Use aluminium oxide at a pressure of 1 bar or 15 psi. Carefully blast the restoration until you have completely removed the reaction layer from the ceramic surface. After that, carefully place the ceramic structure onto the Viteo base, applying only light pressure. Check the fit of the ceramic structure on the titanium bonding base. Existing irregularities can be seen as dark markings on the ceramic. Carefully remove any irregularities with a suitable ceramic grinding instrument. Now, you can separate the sprue using a separating disc. Subsequently, smooth out the attachment point of the sprue. Make sure that you maintain the minimum thicknesses. Check the emergence profile and the fit on the model. Adjust the contours, morphology and texture as required using appropriate grinding instruments.